Okay, let's continue from where we stopped the last class. So in that class we were doing some problems, some examples related to the sections of solids. Today we will continue from there. So question for the first exercise is displayed in the screen. Please note down. A cone of base 50 millimeter diameter, axis 60 millimeter, is resting on its base on the HP. It is cut by a vertical section plane inclined at an angle 60 degree with the XY line and is 10 millimeter away from the top view of the axis. Draw the top view, sectional front view and the true shape of the section. So this is the case of a cone. The base diameter is 50 millimeter and the length of the axis is 60 millimeter. And the condition is that it is resting on HP, with its base on HP. Now, the section plane is a vertical section plane which is inclined at an angle 60 degree with the XY line and is 10 millimeter away from the top view of the axis. So, since it is in the top view, we know that it is perpendicular to HP. It is a vertical section plane, means it is perpendicular to HP, and it is inclined at an angle 60 degree, means it is inclined at an angle of 60 degree with the VP. In the question it is said that it is inclined at a 60 degree with the XY line, so it is easy to draw it in the top view, and is 10 millimeter away from the top view of the axis. So this is a similar case as in the previous one, where we have to find out a section plane which is at some distance from the axis. So here also it is at some distance from the axis. So the same procedure we have to follow, and then there will be something additional also. Then draw the top view, sectional front view and the true shape of the section. So this is the question, and let's see how this can be drawn. XY line, and the circle in the top view. In the top view, if a cone is which is resting on the HP, if we look it from the top view will be a circle. So that circle is here. Now we divide the circle into 8 equal parts. You may divide it into 12 equal parts also. That is, that the angle between two consecutive lines will be 30 degree in that case. So that is also possible if you use the 60 degree, 30 degree, that is 12 equal divisions. In that case, drawing the curves will be easier, but the number of projectors required will be more. Since here we require only 8 projectors, but in the other case we may require 12 projectors. So that means the number of lines will increase in our drawing. So now we name the points A, B, C, D, E, F, G, H. Then the apex point is marked as O. The radius is 25. Then we project from all the points, all the marked points, we project the points. Now we complete the triangle in the front view, and the generators, the front view of the generators, that is also required. So this much is the top view and the front view of the given cone. So that is, drawing this much is very simple as drawing the front view and the top view of a cone which is standing on its base on the HP. Now, naming the front view, the endpoints of the generators in the front view is also done. Now what we have to do is we have to determine all the points which are at a distance of 10 millimeter from the apex, from the axis. So for that one we draw a circle at a radius, with a radius of 10 millimeter, so that the section plane is at a distance of 10 millimeter from the axis. So the circle, the radius of the circle should also be the same, that is the same 10 millimeter from the axis of the cone. So that also we have to draw. Now this is of radius 10. Now we draw a line which is making an angle of 60 degree with the XY line. Since our section plane is making an angle of 60 degree with the XY line in the top view, we draw a line which is making an angle of 60 degree with the XY line. That line is drawn in the top view. That is drawn at some specific distance, some arbitrary distance, not specific distance, some arbitrary distance from the axis, so that it won't intersect with the top view, but it is sufficiently far away from the top view so that we will be able to draw the true shape towards the left side. This 60 degree can be towards the right side also. That is of no problem. In this case, the 60 degree is marked. The line is drawn towards the left. In your drawing, if you feel that it is comfortable to draw it towards the right, then you can draw it towards the right also, no problem. So 60 degree. Now parallel to this line, parallel to this 60 degree line, and touching the circle that we have already drawn, we draw the section plane parallel to this line and touching as a tangent to the circle that we have drawn. We draw the section plane. Now this is our section plane HT. This is, so we have marked the section plane. Now all the newly generated points, in this case actually no new corners are formed. Actually only two new corners will be formed. One on this base edge here. Actually not, it is a base edge on the base. When the section plane is cutting the base circle here, that is one point, that is P, and the other one is here. So there will be only two edges will be formed. The others, all the other points will be just like a curve. There won't be any corners, any specific corners that is generated. So what we does in this case is, wherever the section plane intersects with the generators, that point we consider. Wherever the section plane intersects with the generators in the top view. In this case, in the case of a cone, we are bothered about the not about the edges but about the generators. So whichever generators is sectioned by our section plane, that particular points we consider. So here there will be three section generators are considered. One is here, the second one is here, and the third one is here. So now we project all the points, the points from here, P, Q, R, S, and T. The naming is P, Q, R, S, and T. Now we project from P, Q, R, and T. We can directly project from S, even if it is a vertical generator. So even if we project from S directly, we couldn't identify where it will intersect with this generator. This generator, that is OC. OC is the generator in which the point S falls. So in the O dash C dash where it intersects, that is not clear from that cannot be obtained by using by directly projecting S from here. So it can be anywhere from anywhere in the O dash C dash. So where it is to be found, where is it intersecting with the section plane, that is to be found out using another procedure. So from that I will discuss. Then from P dash we draw the projector, from Q dash we draw the projector so that it intersects with the OA. OA is here, so intersecting with here. Then intersecting OB. The section plane is intersecting OB at R. So this is the point, corresponding point, intersecting at OS, OC. OC at S, we doesn't know where it is, that we have to find out. Then at OT, it is intersecting at this point in the base itself. So 4 of the points are found out and 1 point is to be found out. How to find it out? First we draw. So P dash is marked, Q dash is marked, R dash is marked, and T dash is marked. And in order to find out S dash, what we do is we draw a semicircle. No, actually not a full semicircle is prepared a quadrant of a circle with the center as O and the radius as OS. See this red line. It is with the O as center and OS as radius. We draw a semicircle, a quadrant of a circle, so that it intersects with the top view of the generator OE. So then from that point we project. From that point we project to the projector of O dash E dash. From that point we project to the projector of to the front view of the projector of O dash E dash. And from here, from this point we draw a horizontal line. Now this point will be our S dash. So this is the point S dash. So I'll show it once more. From S, with the center as O and OS as radius, we draw a circle, not a circle, actually a circular arc, so that it intersects with the OE. Then from that point, from the point of intersection of the circular arc and the top view OE, we draw a projector to O dash E dash. And from that point, from the point of intersection of the projector and O dash E dash, we draw a locus to this point, this O dash C dash. And now that is the point S dash. The theory behind this one is in a cone. In a cone, if we have a point here, if we have a point at a distance equal to this OS, then it will be all the points which are at the same distance will be in this circular fashion, in this circle. In a cone, if we have a point lying at S, all the points which are having a distance equal to OS will be in this circle, in the circular curve that we have drawn. So that is the property that we use. Then the corresponding point OS, the point corresponding to OS will be lying in OE at this point. That is the point where the circular arc and OE intersects. And from there we draw it to the O dash E dash, means we find out the point, the distance of that particular point in O dash E dash. Then drawing it towards the left, the same point is projected to the O dash C dash. So that is the concept. So likewise, you can find out S dash also. Now you have to draw freehand curve, not using your scale and pencil, using your pencil only and your hand. You join P dash, Q dash, R dash, S dash and T dash. So then join P dash, T dash also, then hatch it. So this is the sectioned surface in the front view. Now this is the top view. Now in order to get the true shape, from P, Q, R, S and T, from all the 5 points, draw perpendiculars to the section plane. The section plane in this case is the HT, the marked HT, and perpendicular to that particular line, draw projectors from P, Q, R, S and T. Now, we already have a straight line which is perpendicular to all these projectors. So this is, we take it as x1, y1. And now, as our normal procedure, the distance of P dash from XY line, that is marked from x1, y1 on the projector through P. And the same case is for Q, R, S and T. Now join P, Q, R, S and T using a freehand curve. Now this is the true shape. So is it clear? Are you following me?
Yes, sir.
Yeah. Okay, then just note down it and then you can continue it afterwards. Just note down how this can be drawn. Any specific points like finding
Excuse
out.
me, sir.
Pardon?
Sir, നമ്മൾ താഴെ ഈ PQRSന്റെ പ്രൊജക്ടേഴ്സ് ഒക്കെ എടുത്തില്ലേ?
PQRSന്
താഴെ പ്രൊജക്ടർ ഒക്കെ വരച്ചില്ലേ താഴെ?
താഴേക്ക് ലെഫ്റ്റ് സൈഡിലേക്ക് താഴേക്ക് വരച്ചതല്ലേ?
അത് കഴിഞ്ഞിട്ട് ഈ ഒരു ഫിഗർ ജസ്റ്റ് താഴെ കിട്ടിയ ഒരു ട്രയാങ്കിൾ ഇല്ലേ?
ട്രയാങ്കിൾ അല്ലാതെ ആക്ച്വലി അതൊരു മറ്റേ എന്താ പറയാ മറ്റേ പരാബോളിക് ഷേപ്പ് ആണ്.
അത് എങ്ങനെ വരച്ച് വീണ്ടും പറഞ്ഞുതരാം. ജസ്റ്റ് ഒരു
ഇത് x1 y1 ലൈനിൽ നിന്ന് ഡിസ്റ്റൻസസ് മാർക്ക് ചെയ്യുക. ഇപ്പൊ പി ഡാഷിലേക്ക് ഫ്രണ്ട് വ്യൂവിലുള്ള പി ഡാഷിലേക്ക് എക്സ് വൈയിൽ നിന്ന് എത്ര ഡിസ്റ്റൻസ് ഉണ്ടെന്ന് നോക്കുക. 0. സോ ആ 0 നമ്മൾ ഇവിടെ മാർക്ക് ചെയ്യുന്നു. ഇനി ഫ്രണ്ട് വ്യൂവിലെ ക്യൂ ഡാഷിലേക്ക് എക്സ് വൈയിൽ നിന്ന് എത്ര ഡിസ്റ്റൻസ് ഉണ്ട്? ഇവിടെ ഒരു ഡിസ്റ്റൻസ് ഉണ്ടല്ലോ, നമുക്കത് മെഷർ ചെയ്തെടുക്കാവുന്ന ഡിസ്റ്റൻസ് അല്ലേ? നിങ്ങളുടെ കോമ്പസിലോ ഡിവൈഡറിലോ ഈ ഡിസ്റ്റൻസ് മാർക്ക് ചെയ്തെടുക്കുക. ആ ഡിസ്റ്റൻസ് ഇവിടെ ക്യൂബിലൂടെയുള്ള പ്രൊജക്ടർ ഉണ്ടല്ലോ, ഈ പ്രൊജക്ടറിൽ x1 y1 നിന്ന് മാർക്ക് ചെയ്യുക. അതുപോലെ തന്നെ ആറിൻ്റെത് ഓക്കെ, അങ്ങനെയാണ് അത് വരയ്ക്കുന്നത്.